Hi guys, my name is Carolina Lopez and this is my molecular portfolio for Denavir. I'm super excited to show you guys my molecular drug, so let's get started. This generic name, this is the generic name of Denavir. It's called Pensiclover, and then this would be the long version, the chemical name of my drug. I will not say this just because I know for a fact I'm gonna mess up. This is super long, but that's the chemical name. I wrote it out for you guys, and then that is the generic name. So fun fact about this drug is that it actually reduces cold sores. It reduces sore throats, pain in that area. It also helps with herpes and fever blisters as well. So if you know that you are allergic to Pensiclover, do not take this drug. Another fun fact is that women who are breastfeeding or pregnant can actually take this drug. It's super safe, no birth effects, nothing. And also, there's another fun fact. Oh yes, this fun fact is that this drug does actually not interact with any other drug. It's basically independent and on its own. So before we get started with drawing all of the structures, I just wanted to show you guys my molecular formula. So the molecular formula for Denavir would be C10, H15, N5, and O3. And now I'm going to get into the structures. Okay guys, so the first picture that I'm going to draw out for you is going to be the line bond, skeletal structure, and lone pairs. So I'm going to start off with the N. So that is the line bond, skeletal structure, and lone pairs. And on my next part of the video, I'm going to show you how to put all of the C's and H's. All right, guys, so now we're going to do the expanded structure. I'm going to start off on this side again with the N on my left. So that is my expanded structure. And now on my last part of the video, I'm going to show you how to color code everything and know what is a trigonoplanar, tetrahedral, all that good stuff. So part 3 coming up. So now we're going to talk about the VSEPR theory, molecular geometry predictions. So we're going to start off with trigonal planar. So trigonal planar would be this one because it has three lines connected to it. This C is also has 3. This C has 3. This one as well has 3. My blue's running out. And then this one also has 3. And double checking if I missed anything. So those would be the trigonal planar. Next up, we're going to do tetrahedral. Tetrahedral would be over here. So this would be a tetra. This one as well. And these two as well, because they all have 4 connected to them. And now we are going to do trigonal pyramidal. This one will be trigonal pyramidal because it has 3 connected and it has a lone pair. This one as well. And then this one as well. All right. And now we are going to do the last one, bent 120. So this one has a double bond and it's connected to 2, but it has 1 pair of these lone pairs. So this one would be a bent. This one also has a lone pair and it's connected to 2. So that'll be a bent, and they're both bent 120. So now we're going to do the molecular formula and molar mass calculations. So I already have my molecular formula on here. I got this from the periodic table. And now we're just going to do the formula. So it'll be 10 from the C, and then we plug in the 12.011 plus 15 from the H, and then we put that there, plus 5 from the N, and then we plug in this, and then plus 3 from the O, and then plug in the 15.999. Okay, and now we're going to calculate this. So basically simplifying everything, plus 47,997. Okay, and then I simplify this more, so we calculate this and we get 253.262 G mole, and then we round it to this, and then mole. So that is my answer for this section. All right, so this is on page 7. I'm gonna do hydrogen bonding with water. So I'm gonna do all of the bonds. So this connects to O, and this automatically has 2 H's. This one connects to H. This one has an O and an H. This connects to H, and this has O and an H. This one connects to O. And I'm using green. It says to use red, but I'm using green just because I don't have red for my markers. But yeah, this one connects to O. It has 2 H's. This one connects to H, and it has an O and an H. This one connects to H, and it has an O and an H. This one connects to H as well with an O and an H, and then this one connects to O, and this has 2 H's connected to it. And this is what I have. So now I'm going to do hydrogen bonding with water with Denavir. So I already have everything written out on here. I'm just going to connect all of the hydrogens with the water bonds. Checking to make sure I didn't miss an H. But yeah, this is what it should look like. Now I'm going to do polarity and solubility predictions. So I'm going to write out my molecule real quick. So let me do that real quick. All right, so now I'm gonna just put NH2 over here for now. So now I am going to circle all the ones that is the polar portions of the molecule. So basically, this is the polar portion. So we're gonna circle this. And then over here, we have a polar portion as well. And yeah, this is the polarity and solubility predictions. So this is the polar portions. I circled them for you guys. So I also believe this is soluble in water. Denavir should be soluble in water, and I also checked PDR, and they also said that it has water solubility. Now I'm going to do the solution calculations. So for the first part, it says 50.0 ml of 2.30 times 10 to the negative second power M solution of your drug. So we are going to do number 1 first. This should convert to 0.0500 liters. And then now we're going to write out the equation, so of your drug. So yeah, it says 2.30 times 10 to the negative second power mole liters times 0.0500 liters. All right, so now we calculate this and we should get 0.00115 mole. And now I'm gonna do mole of drug times G drug over 1 mole drug equals gram of drug. So that should be what I'm solving for right now. So I plug everything in. So 0.00115 mole of drug. And then times 253. Yeah, that is what I have for the other page. So 253.26 G. And then 1 mole of drug. And that also cancels out. So we're left with this. So we solve it and we get 0.291, okay, so now we solve this and we get 0.291249. And then when I round it, I get 0.291. And I'm gonna put grams right there. That should be the answer for the first part, number 1, and now we're gonna do the second part of this page. So that is my answer for the first part. Now I'm gonna do the second part of this page. I'm gonna walk you guys through. So we're gonna do, I'm just gonna write out the equation for you guys. A lot of steps to this. So this is what we're solving for. So now I'm gonna plug everything in. So this is all with Denavir. And then we're just gonna plug everything in. Just crosses off. Okay, so this is what I did. So basically I wrote everything out, and then so since this is timing 100%, we got to get rid of that. So got rid of this to get basically to solve it now. So we get 0.06 0 G solute. And then now I just go back, plug it in one more time to 1000 mg over 1g, because we're solving for mg, and then we get 60 mg. And that should be my answer for number 2. All right, guys, so this concludes my presentation. Thank you so much for listening to me.